You got to add that in this study. Let's just see how many questions we get through. So question 1. For the angle negative 120, determine the reference angle, a positive coterminal angle, a negative coterminal angle, and the general solution. What a good question. That hits like everything. Trig. Okay. When you're doing angles, the standard way to do an angle is you start on your x-axis and you go counterclockwise. Right? That's the regular way to measure an angle. It's called standard position. If your angle's negative, then you went the other way. So they said that you had an angle of negative 120 degrees. Roughly sketching that means you started at your positive x-axis and you went backwards 120 degrees. It helps to remember that every time you hit an axis is 90 degrees. Right? So this would be negative 90 to here. Negative 120 would be a bit past, so somewhere in here. Negative 180 would be this axis. So we want negative 90, or sorry, negative 120. We're somewhere over here. Negative 120 degrees. That is the standard position angle. It's just negative. They asked us for a whole whack of definitions, so we're going to go through them all one at a time. First thing it said was, what's the reference angle? Reference angle is the angle to the x-axis. The closest x-axis. Good question. Reference angles are always in between 0 and 90. So they're always positive, and it can't go bigger than 90 because if it went bigger than 90, then there was actually a different x-axis you were closer to. Right? You've measured to the wrong one. So our reference angle for this question would be right here. That is my reference angle. Again, it helps to remember like how far everything is. So if I had gone all the way to here, this would have been 180 degrees. So I'm trying to figure out how much more do I need to get to 180? Well, there's 120 to here. That means I need 60 more to get to 180. My reference angle is 60 degrees. The angle to the close x-axis. Perfect. A positive coterminal angle. Coterminal means it gets you to the same terminal arm. And if you think about this like line as like an arm on a clock, it can just like spin around, right? It can rotate. Coterminal angles are angles that would get you to that same spot. The way you get a coterminal angle, especially a positive coterminal angle, is you add 360 degrees. So a positive coterminal angle would be negative 120 plus 360 for a total of 240 degrees. That gets me to the same arm, which is going the other way. A negative coterminal angle is just subtracting 360. So that means it's still going that direction. You're just spinning the other direction. So it'd be negative 480. Those are coterminal angles. They get me to the same spot. And the general solution. So the general solution is a way of describing all angles that get you to that terminal arm. The way you get all angles is by taking your negative 120 degrees, adding or subtracting 360 degrees, times n, where n is the number of times that you do a spin. You do have to define n, because if you don't do a whole spin, then it wouldn't work. So n has to be a whole number. N is an element of the whole number system. You also could rewrite that Same answer, but without the minus. And instead of being an element of the wholes, it could be an element of the integers, meaning you can have negative whole values. So it'd be like -1, -2 spins like that. These are equivalent. They are both general solutions. If it was multiple choice, there would only be one of them there. You wouldn't see both. If it was written response, either answer would be correct. So both are good. Do you guys remember doing that in like Math 20? Like we did do that in 20-1 a long time ago. No. We started doing that in Math 20-1 to try to help you in Math 30-1, like show you some trig stuff. Yeah, we did like trig online, right? Like we skipped all unit circle and trig in 20-1. We didn't do any unit circle last year in 20-1, right? We skipped it all.
Second semester, we just like cut out a bunch of trig because we can't.
Yeah, we did this part, but we cut out something called sine law, something called cosine law, and unit circle. Because those things aren't actually relevant or part of the curriculum, one or the other. We didn't do it.
We didn't do that. You didn't do that. I don't remember doing it at least.
Like if we did, I didn't. Okay, let's do the same thing, but now we're going to do radians instead of angles. Remember that radians is just another way of measuring angles, right? It's just a different term than degrees. It's like saying degrees Celsius and degrees Fahrenheit. Like they're both telling you the temperature. So if I'm telling you an angle in degrees or an angle in radians, I'm still telling you an angle. The angle's not changing. It's the same angle, different measurement of that angle. We're going to sketch 5 pi over 6. When you're sketching these angles, over here is 0. Over here is pi. So from this spot to this spot is 1 pi. If I want to do pi over 6, sorry, 5 pi over 6, that means they took pi and they split it into 6 pieces. So 1, 2, 3, 4, 5, and then the 6th one will be over there. But you see how there's 6 segments? 1, 2, 3, 4, 5, 6 segments to get to a full pi. They want you to sketch 5 pi over 6. So that would be 1, 2, 3, 4, 5 pi over 6. My sketch should go to there. This is 5 pi over 6. And I could do that for anything. Like pi over 6s are actually on our unit circle. Throw back the unit circle. But if they said, hey, I want you to sketch 5 pi over 8, like that means they've broken the top into 8 pieces. You want 5 of them. And then you can kind of estimate where your sketch is going. Sweet, we're going to do reference angle, positive, negative, and general solution. So same idea. The reference angle on this guy is right here. That's my reference angle. Right? To the closest x-axis. My reference angle would be 1 pi over 6. The reason it's 1 pi over 6 is because I need to get to pi, which is a full pi. I'm only missing 1 pi out of the 6 to make it 6 pi over 6. So that would get me here. That's pi over 6. Sweet. Reference angle, done. Oh, they don't do positive or negatives. That's okay. We'll just go right to the general solution. So the general solution is your angle, which in this case is 5 pi over 6, plus a full rotation. But I'm not going to put plus or minus 360 because that would be degrees, and I'm in radians. So a full spin is 2 pi. Remember that 1 pi is a half spin. I want to do a full spin, so that's 2 pi. And then you do have to times that by n, because that's how many spins you choose to do. And n can be an element of the whole number system. It can't be the real number system. because the real number system would be decimals, and we don't want to do a half spin, or else it wouldn't get me back to the same spot. Sweet. Number 3. An angle in radians with a coterminal with 30 degrees is, they're just asking you this in radians. So you could just remember what 30 degrees is from a unit circle. That's legitimate. But I do want to convert angles into radians because I'm not sure if another one of those pops up. So to convert an angle to a radian, you're going to do 2 fractions. The bottom of the fraction is always 180 degrees equals pi. Because I know that's true. If you know the angle, which I do know the angle, that goes on top of the 180. And if I want to know the radians, which I do want to know the radians, that's your x, and it goes above pi. Your fraction on the left should usually simplify. This one simplifies really nicely. So 30 does go into 180. You know, math fracket, and it should tell you it's 1 over 6. So 1 over 6 equals x over pi. Multiply pi to the other side. You get 1 pi over 6 equals 30 degrees. That's my radian measurement. It's not one of the answers. Oh my. So if it's not one of your answers, it's because they've probably done more than one spin, right? 30 degrees is pi over 6. But you could add or subtract 2 pi to that value, and that would also give you a full spin to the same spot. So if you added 2 pi, that's like pi over 6 plus 12 pi over 2. Right, get a common, 12 pi over 6. Get a common denominator. That's 13 pi over 6. That's still not an answer. I see negative 13 pi over 6, but I don't see positive 13 pi over 6. I'm going to try again. So I'm going to take 13 pi over 6. I'm going to add another 2 pi, so another 12 pi over 6. And I get 25 pi over 6. That answer is there. D is coterminal with 30 degrees. The reason I knew to keep adding 2 pi is because 13 was still smaller than one of my possible answers. So say I had got like 26 over 6 or something like that, then I would have stopped adding and I would have started subtracting 2 pi to see if it's one of the negative answers. Cool. Another way through that question. Once I figured out that it was pi over 6, I could have taken my answers and I could have added or subtracted 2 pi to those to see which one of these would eventually turn into pi over 6. Remember, we kind of had that trick of anything that's bigger than 2 pi, so for instance, like 25 pi over 6, I could just subtract 2 pi from it to make it smaller and smaller and smaller until it's something that I'm more comfortable with. Same with negative ones. I could make negative ones positive by adding 2 pi, right, until it eventually turns positive. Yes, sir?
Can you add and subtract 360 though from both?
You could.
Because if you do that, D is also an answer. You had 30 degrees, you took away 360, you would get negative 13 pi over 6.
So you took pi over 6. You subtracted 12 pi over 6. That's negative 11 pi over 6.
So like I converted the negative 13 pi over 6 to
degrees?
2 degrees.
What did you get for degrees?
I get
should be
negative 390.
That's right.
Degrees. But then if you add, I guess if you add 360 to that, you get
that's negative 30. Yeah, which is why it didn't work. And then if you added another 360, it'd become positive 330. So it doesn't match up. That's good. That's really bad. Just switch it with somebody else. Just don't tell them. Go ask Miss Shaw if you can borrow her calculator and then give her that one back. Like, oh, I got it like that. That's like a standard move, right? Please don't do that. That's theft. Yeah, that's on recording. Sorry, Miss Shaw. I don't know why all your calculators are broken. Okay, we're going to determine this reference angle. It says, I can barely read that. Hopefully you can. A point is on a terminal arm in standard position as shown in standard position. The standard angle of the terminal arm is 16 pi over 9. You guys can't read that? Clear as mud. I don't know if that's right, but I'm going to 16 pi over 9, and we're going to work from there. So we have this. 16 pi over 9. That? Yeah, right? That's kind of what I was going with. I'm just really banking on that being a 9 on the bottom. If it was an 8, they would have simplified it. So I'm pretty confident it's 16 pi over 9. Yeah. They ask you to determine the reference angle. Looking at this, the reference angle is this angle right here, right, to the closest x-axis. You're trying to figure out what would complete that circle to 2 pi. But because it's over 9, I could also think of this as 18 pi over 9. And I'm asking myself, like, how many pi's do I need to complete that circle? I would need 2 pi over 9 to complete that circle. Is that one of the answers? Oh, then it must be. Reference angle, closest x-axis. All right, convert to radians, convert to degrees. I'm going to rip through this. So you go 2 fractions equal each other. 180 equals pi on the bottom. Put what you know on top of what's the same, like that. This is going to convert to be 5 pi over 18 equals x. The other one, same idea. I'm doing x over 180 is 5 pi over 7 over pi. You convert that. You get 180 times 5 divided by 7 because those pi's will cancel out. You had 900 over 7. That's terrible. What the heck? That's such a bad number. Did I mess up? The pi's are going to cancel. Right? Because you kiss and flip. Pi's on the bottom. That cancels out. So I need to multiply the 180 over. Well, yeah, 180 times 5 divided by 7 is just a terrible number. So as a fraction, it'd be 900 over 7. As a decimal, it'd be 128.6 degrees. Yeah, well, I rounded it. It was 128.57 something. Just remember, you're making equivalent fractions. 180 equals pi on the bottom.
So exact value.
Exact value would be 900 over 7. Who chose to divide by 7? That's all.
My bad.
Thank you.
Thank you.
Trig word problems. Everybody's favorite thing. Okay. A rotating water sprinkler makes 1 revolution every 15 seconds. The water reaches a distance of 5 meters from the sprinkler. What is the arc length of the sector watered when the sprinkler rotates after 10 seconds? Give your answer as both an exact value and an approximate measure to the nearest hundredth. Okay, let's sketch this. You got a sprinkler in the middle. It rotates. It makes 1 revolution. So that's 1 full circle every 15 seconds. So it shoots, makes a full circle. That takes 15 seconds.
That's an amazing circle.
Thank you. The water reaches a distance of 5 meters, meaning that from the center of the sprinkler to the edge is 5 meters. What is the arc length? Arc length is distance on the outside of the circle. So what is the arc length of the sector watered when the sprinkler rotates after 10 seconds? So we know 15 seconds is a full cycle. It only did 10 seconds, so it did not do a full spin. It went from here, and it went around, and we don't know exactly how far it went. We just know it went for 10 seconds. Your job is to take those times, 10 seconds and 15 seconds, and figure out how far around the circle you got. To do that, you go 10 divided by 15. 10 is how long I went for. 15 would be a full cycle. That means this did a cycle of 2 over 3. So I did 2/3 of a spin. My sketch is pretty close there for 2/3. Let's do this. It's not bad. This distance is 2/3. Okay, our goal is to figure out arc length, which is this purple distance. Anytime you want to figure out arc length, you're going to use your arc length formula. It is right above you. It is on your formula sheet. So the arc length is up here. That's the arc length equals the radius times the angle. Angle must be in radians. We don't currently have an angle. 2/3 is not an angle. I'm saying I've done 2/3 of a rotation. I'm not saying the angle is 2/3. To figure out that angle, you need to do 2/3 of a full spin in radians. So a full spin is 2 pi. So I need to do 2 over 3 times 2 pi. And that will tell me my angle. 2 over 3 times 2 pi is 4 pi over 3. Because I did 2/3 of a spin. If I did a full spin, that would have been 2 pi. So if I do 2/3 of 2 pi, that'll tell me what 2/3 of a full rotation would be in radians. We did questions like this before. I'm trying to remember which ones we did part spins on. There was the ankle one, right, where they were doing a skipper or whatever. You had to be able to take like a proportion of a spin and then apply that to a full spin. So I'm taking a proportion of a spin, I'm applying it to a full spin to figure out my angle.
How come you're not doing a common denominator?
Multiplication doesn't need a common denominator. That's adding, subtracting. Yeah. Perfect. Now I can just use my formula. The length, arc length, is equal to the radius, which is 5, times the angle, which is 4 pi over 3. The arc length to the nearest, we'll do an exact value and then to the nearest. As an exact value, 5 times 4 is 20 pi over 3. That's the exact value. If you were to round that, 20 pi divided by 3 is 20.9. Did it say nearest hundredth? 20.94. 94. Yeah, it is approximate. Yeah, you should. What he's saying is like it's not equal; it's approximate. When you round something, you should do that.
Because if I was to do that on I'd have to put the little screw back.
Otherwise, it'd be wrong. Yeah.
Are they written wrong?
Yeah. But they would ask for an exact value. If you just write like me, everything looks like a wiggle anyway. So. Should I give unit? What is the units? It would be meters. Yeah. Would you be docked for not putting the units? Not in my experience. You would not be docked for not showing the units. You would not be docked for not showing the swiggle.
I'm always scared to put units because if I get them wrong, it's just awkward.
That's how I always was. I don't want to put the wrong unit, and then they're like, "No, you're an idiot," and then they give me like no marks. I'm like 20.94 seconds, and they're like, "What an idiot!" And give me like nothing. Yeah. That's my fear. And then the physics people are like, "Units matter." I'm like, "Prove it." Number 6. On a circle with radius 4.1 and arc of 18.3, subtends the central angle of the nearest tenth of a degree is. Okay, so I've got a circle. This circle will be nicer for you. No, it won't. That's a line. Look at that circle. Draw a circle as nice as me. With radius 4.1. Center of the circle to the edge of the circle, 4.1. An arc of 18.3. So that means if you go around the outside, that's 18.3. Subtends a central angle. So that means they're talking about this angle right here. Remember that our arc length formula is always referring to the angle in between the two radiuses that you're measuring the arc length. So if they had asked for the angle out here, my arc length formula wouldn't work. If the arc length formula is doing the angle that's inside of your arc length. It's like contained in that little piece of pie that you've created. We want to figure out what that angle is to the nearest degree, so let's use our formula. A equals R times theta. We can rearrange that to be A over R equals theta. That means for 18.3. Thank you, that's what I said. 4.1 equals theta. This is in radians. Look at that internet connecting all my lines. That says radians. We want degrees, so you need to convert it into radians. Do your little 180 equals something over pi. We know the radian measurement. It's 18.3 over 4.1. We want to know the degrees, so the x is over the 180. You're going to get a decimal here, so cross multiply that 180 over, and then just throw the whole thing in your calculator. You go 18.3 divided by 4.1, divide that by pi, multiply that by 180, you get 255.7. 255.7. A. My sketch is atrocious for a 255 degree angle. It's much closer to a 90 degree angle. All right. More practice questions. Number 1, if -3 comma -4 is a point on a circle, determine the value of sine theta. When we get points, you want to sketch it. Your trig unit, you should sketch dang near everything. Honestly, if there's a question, try to sketch it. It almost always helps. Let's sketch what's going on here. I went -3, -4. That means 3 to the left, 4 down. I'm down here. When you get to the trig part of your test, everything's a triangle. There is a triangle here. The triangle is what happens when you do those coordinates, which is 3 to the left and then 4 down. By connecting to the origin, you have a nice little triangle. We call the hypotenuse r because often we are talking about circles. So r means radius. This isn't a circle right now, but that's just the standard notation we'll use for hypotenuse. No, h is gone.
That's what we use.
Yeah, that's what you'd use normally. Sine of theta. People get this concept that sine means y. It does mean y. If you're on the unit circle. If you're on the unit circle, you have a radius of 1. This thing can't possibly have a radius of 1. The reason it can't possibly have a radius of 1 is the radius is the hypotenuse, which should be the biggest side line. So sine is not -4. Sine is opposite, which is y, over r. So you have to find r to be able to figure out what sine theta is. It's a beautiful triangle. To find r, we're going to use Pythagorean Theorem. Pythagorean triples. You should get 25 equals r squared, which means 5 equals r. Yeah. So sine theta equals -4 over 5. Your hypotenuse will always be positive.
That's the answer.
Wait, but if your calculator actually
So it's, I think, a mix between like two ideas and questions here. This is the ratio for sine theta. This is what sine theta equals. If they ask you for what theta equals, that's a different question, right? They're asking for the angle that would create that. They did not ask for the angle. They asked for sine of the angle. Sine of the angle is -4 over 5. Had they switched the question and said, what is the angle? Then I would have to calculate this angle that gets me there. And that's when I drop the negative to find the reference angle. And I would do 180 plus the angle that's a reference angle, which I think is what you're asking, Kyler. Sine of theta is -4 over 5. They're asking for a ratio, not an angle. Make that very clear. If I wanted to find the angle, and assuming they want the standard position angle, to find the standard position angle, I need to figure out this angle first, which is the reference angle. You find the reference angle by using sine of theta. So you would, in your calculator, go sine of 4 over 5. Notice that I'm doing +4 over 5 because that helps. That's how you find reference angles with positive values. Just do it. That'll tell you the reference angle. I don't know what. Oh, sorry. Not sine, negative sine. So second sine. Sorry.
Should you be in radian?
Let's do degrees because then I don't have to do radians.
Should you ever be in radian for anything?
Anything that's supposed to be in radians, like if it says radian mode or you look at all your answers and it's all in radians, then you should do radian. Like this question doesn't exist, so we're just going to say it says degrees. But if it said radians, then I'd have to do radians. So this portion is 53 degrees. So theta would be 180 plus that 53. That would be 273. No, 233. Again, that's the angle. So if they ask you for the angle in standard position, that's what you do. If they ask for sine of theta, you don't do that. That work, Blake? Yeah. Pardon? Does it? At some point it will. Like it very well could. Okay, number 2. Determine the missing y-coordinate for the point -1/5, comma y if the point is on the unit circle in quadrant 3. Okay, they give you a point. You're clearly in your trig unit. Sketch that. Sketching that. I'm in quadrant 3. The quadrants go like this. If I'm in quadrant 3, my sketch is down here. My triangle has an unknown y value, an x value of -1/5. And you know the radius. It says it's on the unit circle. So your radius is 1, right? On the unit circle. And now you've got yourself a nice little sketch of a triangle. You're trying to find y. If you have two sides of a triangle, to find the third one, you do Pythagorean Theorem. So this is going to be 1 squared minus -1/5 squared equals y squared. Put that in your calculator. That's 1 minus 1/25 equals y squared. 1 minus 1/25 is 24/25 equals y squared. When you square root both things, you get root 24/5 equals y. Remember, you square root the top and the bottom of the fraction. That is not the right answer. The reason it's not the right answer is because root 24 can be reduced. So simplifying radicals. Find a perfect square that goes into 24. 4 goes into it. The square root of 4 is 2. This is 2 root 6/5 equals y. It's not terrible. Oh, when you calculate it? It's also wrong. Why is that the wrong answer? Because that's positive 2 root 6/5. Look at where we are in our graph. We are in the bottom half of the graph, meaning that the y value must be negative. So this is actually negative 2 root 6/5. A lot of people get to here, right? You square root, you get a decimal answer, and you don't know what to do. Right? Don't change it into decimals. Leave it as an exact value. Do the math, like simplify each part, and then check if your negative's right. Okay with that? Bueno. All right, this guy. If cotangent of theta equals -3/4 and cosecant of theta is less than 0, then the value of sine of theta is okay. Every time they give you a ratio, they're giving you two sides of a triangle. You should sketch that triangle. Let's start by changing cotangent of theta to something we're more comfortable with, because that's a good habit. Cotangent, you could change into tangent by flipping that fraction. People typically like to work with tangent instead of cotangent. Tangent also tells you opposite, which is y, over x. So they've given me two coordinates. They give me a y coordinate, they give me an x coordinate. We don't know where the negative is. We don't know if the negative is with the x or with the y. So technically you have two triangles right now. Like technically, this could be over here, which would be -3, +4. Or they could technically build it down here, which is +3 and then -4. We don't know where that negative actually is. That's why they have to include this little bit here. That narrows it down for us. That means that cosecant of theta is negative. Cosecant is 1 over sine of theta is negative. That means sine is negative. Sine is negative when your y value is negative. So it's not in that quadrant because your y value has to be negative. That means this is my sketch. 3 to the right, 4 down. Now they want us to calculate sine of theta. Sine of theta equals y over r. So I'm going to have to find r. We've already actually done this one. R is 5. So if you did Pythagorean Theorem, you'd get 5 again. But we already did that triangle. That means sine of theta equals negative 4 over 5. A. Yeah, kid.
It's just y over r because it would be opposite over hypotenuse.
You got it. Yeah, because it's just SOHCAHTOA. Like, honestly, like, most of our trig is still Pythagorean Theorem and SOHCAHTOA. So, yeah, opposite over hypotenuse.
It's easier to remember than the y over x.
Yeah, that's
if
fair.
You know that like, y is O and then r is H.
I, like, always rely on SOHCAHTOA. Truly, I do. So, I would do the same thing in your head that you're
I
doing.
wrote it down one time. On my calculus, I wrote SOHCAHTOA down.
Yeah, it's
Make sure I had it right.
that's honestly what, like, 95% of trig still comes down to a SOHCAHTOA. Like,
That's all I remember.
Just much harder.
the basics. It's all foundational skills up. All right, let's quit.